ডিয়ার স্টুডেন্টস, তো আজকে রে অপটিক্স ক্লাস 12-এর পার্ট 1টা শুরু করছি। ঠিক আছে, সো রে অপটিক্স মানে আলোক বিজ্ঞান। আমরা আলোর গতিপথ বা আলো যদি একটা জায়গা থেকে আরেকটা জায়গায় যায়, একটা মাধ্যম যদি পরিবর্তন করে, তাহলে তার কিভাবে তার চেঞ্জ ওভারটা হবে, আমার কী ভ্যালুগুলো তার ক্যালকুলেট করতে হবে বা তার থেকে আমরা কি ইনফারেন্স পেতে পারি, তো ওই সব জিনিসগুলো নিয়েই আলোক বিজ্ঞানটা। ঠিক আছে, তো তার আগে আমি একটা জিনিস বলতে চাই, আমি যদি অপটিক্সটাকে ডিভাইড করি, মানে অপটিক্স মানে হচ্ছে আলোক বিজ্ঞান, মানে আমি ব্র্যাকেটে লিখলাম লাইট। সো তার দুই ধরনের নেচার থাকে। একটা হচ্ছে হুইচ উই কল ইট রে অপটিক্স, আর আরেকটা প্রপার্টি হচ্ছে তার ওয়েভ অপটিক্স। ঠিক আছে, তো কেন এইটা রে অপটিক্স, এইটা কেন ওয়েভ অপটিক্স? একই জিনিস, একই অপটিক্সকে, একই ফেনোমেননগুলো, রিফ্লেকশন বলো, রিফ্র্যাকশন বলো, হোয়াট এভার ইট মে বি, উই ক্যান অ্যানালাইজ ইট বাই রে অপটিক্স অলসো বাই ওয়েভ অপটিক্স। তো কেন আমি রে অপটিক্স বলছি, এখানে লাইটটাকে এমনিতে বলা হয় কর্পাসকোলার নেচার, মানে সোজা কথায় হচ্ছে এটাকে আমরা পার্টিকেল নেচার হিসেবে ভাবতে পারি। অ্যাজ এ লাইট, অ্যাজ এ পার্টিকেল ভাবা যায়, এবং ওই কনসেপ্ট দিয়ে রে অপটিক্সটা সমস্ত কিছু ডিফাইন করা হয়ে থাকে। আর ওয়েভ অপটিক্সটাতে এখানে লাইট অ্যাজ ওয়েভ হিসেবে এক্সপ্রেস করা হয়। এখানেও আমাদের ওয়েভ অপটিক্স বলো বা রে অপটিক্স বলো, হোয়াট এভার ইট মে বি, এখানে সবসময় অল ফেনোমেননস ক্যান বি ডেসক্রাইবড। তো আমরা প্রথমে রে অপটিক্স নিয়ে পড়ব, অতএব ওয়েভ অপটিক্স নিয়ে মাথা ঘামানোর অ্যাট প্রেজেন্ট আমাদের দরকার নেই। এবার রে অপটিক্সকে আরেকটা নামও বলে, সেটাকে বলা হয় জিওমেট্রিক্যাল অপটিক্স। কারণ রে অপটিক্সের যত ডায়াগ্রাম আমরা করব, উইল ইউজ দ্য বেসিক ইউক্লিডিয়ান জিওমেট্রি, একদম বেসিক জিওমেট্রি আমরা ইউজ করব। সেই জন্য এটাকে জিওমেট্রিক্যাল অপটিক্সও বলা হয়। সো রে অপটিক্স আমরা ঢুকি, তাহলে আমি দেখলাম যে রে অপটিক্সটাতে আমরা লাইটের পার্টিকেল নেচারটাকে হাইলাইটেড করা হয়, আর বেসিক্যালি এটা জিওমেট্রি, বেসিক ইউক্লিডিয়ান জিওমেট্রিকে বেস করে সেটা করে, তো সেই জন্য এটাকে জিওমেট্রিক্যাল অপটিক্স নামেও বলা হয়ে থাকে। এবার আমি মেইনলি দুটো, ধরো আমরা যদি বলি লাইটের, একটা হচ্ছে রিফ্লেকশন, মানে বাংলায় প্রতিফলন, another is refraction, বাংলায় প্রতিসরণ, then we have dispersion, and we are also having scattering. So এরকম অনেক আমরা লাইটের নর্মাল রে অপটিক্সে আমরা ডিসকাস করতে পারি। সো একটা একটা করে ঢুকছি, প্রথম রিফ্লেকশন পার্টটায় ঢুকবো, then we will go refraction, then dispersion, then scattering. So sequentially I will maintain these things. So first of all we go for reflection. Let me clear the board. So reflection is our first topic. So we have a topic called reflection. Your reflection type is a process where the light will be reflected back, going from the medium and returning back to the medium, obviously from a polished surface, a smooth surface. তো এই রিফ্লেকশনটা দুটোতে হতে পারে, একটা হচ্ছে প্লেন সারফেস, you have a plane surface, preferably smooth surface. একটা এক্সাম্পল হচ্ছে মিরর, প্লেন মিরর। আরেকটা হচ্ছে কার্ভ সারফেস। एग्जाम्पल बोला जाए concave mirror. So these are examples. So regarding the reflection from the plane surface, that is the plane mirror, is very easy thing, and already these things have been done in previous classes like class 10. Even the reflection from curved surface is also have been concluded in the class 10 syllabus. But let me again recapitulate this curved surface, and I will give some formula regarding the plane surface reflection. These formulas are only for numericals. If you want to do any numerical using this formula, then that will be helpful. So I am giving some very basic fundamental about the plane surface reflection. So you one thing you know, that is the laws of reflection. If you have a plane mirror, it goes here and then goes back. You have a normal. So this one is I, this one is R, and plane surface it is I is equal to R. Another thing is that if you have a mirror here, you have a object which is at a d distance. This is my object. Then you will have an image. This is an image which is also having the same distance. That means we call it U is equal to V. U is object distance and V is image distance. So these things are very trivial things, and you have done it already. That is nothing new in it. Then another formula is suppose two mirrors are, these two plane mirror, and this is angled with itself is theta. So if you put an object here, so you have number of image n is equal to 360 by theta, all in degree minus 1. So if the angle is 60 degree, you will have 360 by 60, that is 6 minus 1. So you will have 5 number of image. If you have theta 90 degree, you will have 4 minus 1, so that will be n is equal to 3 image. You can also have that famous experimental setup, which you can do it in yourself in your home. So no need to go for any lab or other things. So I have having a mirror here, and another mirror I have put it. So the angle is 90 degree. So as per the formula, I will have 360 degree by 90 degree and minus 1. So it gives me 3. So I will have number of image is equal to 3. Now how this is the calculation, mathematical part. I am telling that there will be number of images will be 3. Now how to clarify these things? So you have a object here, say O. This one is the mirror, and this one is also mirror. So you will have an image of this O in somewhere here. So let it be image 1, and you will have O, let it be mirror 1, and this is mirror 2. So you will be having one image of O will be here, another image will be here. So it will be image 2. Now what will happen? This image 2 will be seen as object of M1. So again it will make another image, let it be 3, and image I1 will be seen as an object by M2. So it will again transpose this image into that point, and this will be in a coinciding with I3. So practically you are having this I1, this I3, this I2. So you are having 3 images, and this one is the object. So my calculation that n is equal to 3 is quite accurate. So in this way you can make for any values of theta, you can calculate the values of n. So this is all a thing about number of images formed when the two plane mirror is inclined at an angle theta. So I think you got this. This angle is 90 degrees. So I am actually verifying the formula by practical explanation. So now if you say that a very trivial question is very easy, and perhaps you have seen it in the barber shop. Suppose you have a mirror here, and you have also a mirror here. Now you are standing here in front of, in between these two mirror. So how many number of images you will see? Okay, have you seen it in the barber shop? You have a mirror here, say M1, and you have a mirror 2, M2, and this is your object. So number of images will be infinite. Theoretically it will be infinite, but practically after a certain times of multiple reflection, the intensity diminishes and absorption becomes dominant, so that you don't get those final large number of images. So theoretically it is infinite, but practically a huge number of multiple images in both the mirrors will be there. So a number of images is infinite, because now from that formula where I have used n is equal to 360 by theta minus 1. So here theta is what? No angle, two parallel lines. Theta I can take it as 0 degree. So n becomes infinite. In a crude form, that is actually mathematically this is undefined. If it is anything comes under 0, undefined, but I can call it as infinite, the number of image. In the practical real life, these two images, this undefined case and the infinite numbers, they actually coincide in after a certain number of reflections, and the image is diminished and absorbed by the medium. So these are the things, one thing. Another one is that if you have a mirror, plane mirror, where the practically a reflection is being occurring. So what is there? This is the mirror. Okay. So one ray is coming out here, and then it reflects back. So this is my normal. Now what I have done, I have rotated the mirror by an angle theta. Anyway, it may be clockwise, it may be anti-clockwise, it does not matter. In any way you rotate the mirror by say theta degree. Okay. So what will be the now situation? This mirror will be like this. That was the initial position. Now I have rotated it by n theta in anti-clockwise. So this side they will be rotated like this. Now what will happen? This ray, incident ray is kept same. Now the reflection will be changed. Now this is the reflected ray in the second case. Initial, let it be, second case, let it be done. Second case. So this is the reflected ray on second case. So I have rotated the mirror by an angle theta. So the reflected ray will also be rotated by an angle 2i theta. This is a there is a proof, but I don't think that this is at all required. This proof is not required at this stage. So I can say if mirror being rotated by theta, then reflected ray rotates by twice theta angle. Remember, this theta is the angle, so it is I am going for angle. Now if I say that this all this rotation has been done in the same time frame, so when the mirror is rotated, that say they took the time of say 2 seconds, the simultaneously the reflected ray also rotated within that 2 seconds. So the time is same for theta rotation and 2 theta rotation, the time is same. So I can say if the mirror rotated with angular velocity omega, the reflected ray will be rotates with angular velocity twice omega. So these 2 points are very similar and very easy to remember. So for solving numericals you can use these two things. Two information is quite handful. So again we repeat that if the mirror is rotated by a theta, the reflected ray will rotates by 2 theta, and if the mirror is rotated by angular velocity omega, the reflected ray rotates by angular velocity twice omega. So this is all things I am doing for plane mirror, that is a smooth surface. Okay, that smooth surface is actually providing us the regular reflection. All these things is used for regular reflection, that is regular reflection is the reflection in which that I is equal to r, that is the incident angle and the reflecting angle, they both become equal, and the object distance and the image distance also remains equal. This is called regular reflection. But in case of irregular reflection also, object and image they might be same, remaining same, but the angle might be different. Let me show you an example of irregular reflection. This is a surface. So whenever you are having parallel rays coming, so if it comes here, it will go like this. it goes like this, and if it comes, it goes like this. So this is a irregular reflection. Here you cannot say that incident angle and the reflecting angle is remaining same. But one way logic is there. If I take the small segment of a curved surface, suppose if I take this surface, okay, or this amount of surface, the very small teeny surfaces. Now if I say that I am drawing a perpendicular here, now this may not be perpendicular for the whole surface. If I consider this amount, this part of the surface, this one is not perpendicular to that one. So this perpendicular drawn at this point might not be the perpendicular to for the whole surface, but if I consider this segment only, say for this segment, so the rays are coming and they are going. So now if I draw perpendicular, in this case this incident angle and the reflecting angle might be equal. Remember the point, for the whole surface it is not equal, but if you take the very elementary surface, very small surface, dx amount surface, dx amount surface length, so at that surface only that might be a regular reflection, but when you consider this one for the whole surface, that might not be a regular reflection, rather it may be a, it can be, might be a irregular reflection. So okay, so these things are for reflection through plane surface, plane smooth surface. Let me go now to the curved surface. Now you see the last diagram that I have done for irregular surface. If I make a mirror of this type of surfaces, this is a mirror, so I will call it a irregular surface. But it has a curvature also. You see, this is having a curvature. Here a type of curvature, here a type of curvature. So curvature is not equal at all points, but still it possessing some curvature. So what will happen? This can be called as a curvilinear surface. That means the surface may contain curve segment, may contain some linear segment, may contain some in between these two. So this can be called curvilinear surface, but we will not go into those critical surfaces, rather we will be go for regular curved surfaces. So our concern will be regular curved surface. That means, say this is a ellipse, this is a circle, this is a curved, but there is a regularity in the surface, there is a symmetry in the surface. Okay, this is a curved surface, but there is a symmetry or regularity or something. You can say that this is a circle and having a radius fixed. At any point the radius will be remaining fixed. In case of ellipse, you can say there is a major axis, minor axis, which is fixed for a specific ellipse. So this type of surface is called regular curved surface. So our concern will be regular curved surface at this stage primarily. So how to make this regular curved surface? You make a sphere, hollow sphere. Make a hollow sphere. Now you take this segment and this segment, and make this one, you make it silver mining here, and here inward structure you gave the silver lining. So now what you have got, now you break it out. So you are getting two regular surface mirror. Obviously you know this is called concave and this one is called convex. In অবতল, উত্তল. So the first thing which comes to our mind, that this is a part of a sphere, isn't it? Initially it was a sphere, so this is a part of a sphere. So if it is a part of a sphere, sphere has a curvature or a radius of curvature, whatever you like to say. So this concave and convex mirror, this is a mirror, okay? So they will have a curvature and they will have a radius of curvature also as well. অবতল দর্পণ তারও radius of curvature থাকবে, উত্তল দর্পণ তারও radius of curvature থাকবে. So one thing I have got, this will have a radius of curvature. যেহেতু এটা দর্পণ, so as like a mirror, it will have a object, it will have a image. So a object distance, image distance will be there. So object distance, image. So these three things will be present for a concave or convex mirror. We are considering about mirror, so there is a convex and concave mirror. Now one very famous term it comes. Consider a concave mirror. What will be the case? You see, here is the concave mirror. So this is called axis and this one is called pole. This is a concave mirror. Remember the shadow, the shading part, if you go outwards it will be concave, if you go inward it will be convex. Now you put some parallel rays and you see they meet in certain point. So if you complete the sphere of the so you know this is the radius is here. So surely this point is not the radius. So this is another point called focus. Both case, in case of convex mirror, because concave and convex both came from a sphere. So sphere will have a radius. So naturally concave and convex they will also have a radius. So this radius point, the center of radius is not the same point where the parallel rays are incoming and after being reflected they got into the point, that is not the same point. So we call this the focus. Now there should be a relation how to find this focus with the radius of curvature. So one formula is there that directly we can say. This is done in class 10, so I am not going very elaborately into that part. So this is the focus is equal to radius of curvature by 2, that means f is equal to r by 2. So, you know, if you know the radius of concave and convex mirror, then you can also tell about the focal length. Now, one question is there from my end to the students. Suppose I have a concave mirror here, which has a focus f. I have a concave mirror which have a focus f. Now, if I have now, it is in air. Now, I have put all this full setup into water, or let me say in another way, I have put some water in the mirror. Now, my query is that will the focus change or not? It is very conceptual question. There is nothing there to think very hard of a problem. It is a very simple thing. একটা কনকেভ মিরর আছে, তার মধ্যে ফোকাল লেংথ এফ। অবভিয়াসলি আমি এফটা জানলে আমি আরটা পেয়ে যাব। সো এফ জানা মানেই আমার আর জানা। অ্যান্ড আমি কি করলাম, আমি তারপরে এটার মধ্যে পুরোটাকে জলের মধ্যে ডুবিয়ে দিলাম। সো মাই কোয়েরি ইজ নাও দ্য ফোকাল লেংথ উইল চেঞ্জ অর নট। Now, you see, this is the focal length relation with the radius of curvature. So, unless you change the curvature, the focal length will be remaining same. Now, আমি just mediumটাকে চেঞ্জ করলাম, বাট আমি radius of curvature চেঞ্জ করলাম না। So, whatever may be the medium, the focal length will remaining same. For only it is convex or concave mirror. Don't think it for lens. Maximum students mix up it with the lens. No, lens will be, focal length will be changed. I will show it in due course of time, but in case of mirror, the focal length will not change as the r is remaining constant. So, focal length relation we have got. So, from radius of curvature we have got the focal length. Now, about the object image and focus distance. Okay. Suppose you have a mirror here. This is focal length, this is f, this is r. Okay. Let it be f, let it be r. This is a concave mirror. I have put an object here, so I got a image here. This is my object, this is my image. So, this is the pole. So, this distance is u, this one is focal length f, and this one is image distance v. So, these things are related with one formula, 1 by v plus 1 by u is equal to 1 by f, or you can replace this f with the value of r. So, you get 2 by r, whichever is applicable you use this formula. So, this is the formula connecting object, image, distance and the radius of curvature and the focus. So, now one very cautious point is there. You have to maintain it, otherwise the formula will be remaining same, but your numerical answers will not be coming. The formula is 1 by v plus 1 by u, 1 by f, or you can say 2 by r. Fine. When you are going to use this formula, you use sign convention. That is very important. Sign convention. There is a topic called sign convention. Sign convention is very important, because in case of lens, in case of mirror, wherever you go you have to use these things. There are a lot of sign conventions, different types of sign conventions. One is Cartesian sign convention. The sign convention which I think is very easy to remember is that I will measure all the distance from the pole. So this pole is here. So all the measured distance, if it comes from against the incident ray, the distance will be negative. If it comes in favor of the ray, it becomes positive. So in this case, you see, I am measuring this distance from the pole, but the incident ray is coming from here, so it will be minus u minus f minus v. So while using this formula here, in this case it should be 1 by minus v plus 1 by minus u plus 1 by minus f. At first you use this negative Cartesian sign, then you go for calculations and you rearrange your negatives and all these things. So this is the sign convention part, which is very important. You can solve a problem, but for only part of a sign convention you will make it wrong, the result will not come. So next class I will again, starting from the sign convention, I will spend some time on sign convention and then I will go to the deeper topic. Okay, thank you.